Hi everybody, this is Eugene O'Loughlin and welcome to my series of short how-to videos. In this video, we're going to learn how to calculate the confidence interval for a sample, and we're going to learn how to do this by hand. So first off, let's take a look at the data that we're going to use in this example. I've used this data before in previous videos. These are the data for 14 randomly selected bags of food which weigh 1 kilogram or 1,000 grams. So we've randomly selected those from a production line as part of a quality control process. And we want to be able to do some statistical calculations with these data. So the first thing I've done with these sample of 14 here is I've worked out the sample mean, and we can see the sample mean x bar is equal to 996.21 grams. S is the standard deviation, that works out at 5.65, and N, the sample size, is 14. So we're going to need some of these values in our later calculations. Let's take a look at the t-distribution. This is a typical t-distribution, our friend the bell-shaped diagram here. And what we say for 95% confidence is that if it's bell-shaped like this, with the population mean mu in the center here, 95% of all values fall between this area here, the vast majority of the bell shape. And 5% fall into the left and the right tail, so half of 5% in the left tail and half of 5% in the right tail. So what we need to know here for our sample size is what is the value, what is the t-value here at each of these margins, at each of the tails. So we're going to need to look those up in t-tables. So let's go ahead and do that first. So these are t-tables here, and they're widely available online. And there's two things we need to know. We need to know down the left-hand side here what the rho is, and that's based on df, degrees of freedom. So we're going to need to have to work out the degrees of freedom for our sample size of 14. And we also then need to know what is the confidence level that we want to do our test at. So we're doing it at 95% here, or a value of 0.05. So the degrees of freedom, first of all, are straightforward enough. The degrees of freedom is equal to n minus 1, which is equal to, in our case, 14 minus 1, which is equal to 13. So we have 13 degrees of freedom. So let me go and look this up on the table. So on my row here of 13, so somewhere on this row, if I just highlight the row, somewhere on this row is my t-value. Now, how do I select the column? Well, the column is, I can do it in two ways. One is I can, across the bottom in this version of a t-table, look and see 95% here, so that'll be in this column. Or at the top, I can choose, we've got two tails, the value of 0.05. So somewhere on this column is going to be my t-value, and where the two values cross over is the t-value I'm going to need. We can see that that is 2.160. By the way, if you wanted to do a 99% or a different value here, you would have the same degrees of freedom in this sample size, but you can see here it would move over. So for example, at 99% confidence interval, my t-value is going to be 3.012. But we're going to stick with 95% confidence for the moment. So my t-value is equal to 2.160. So that's these values here is 2.160 and minus 2.160 here on the left tail. Now that value is going to become important in a moment. Next, we need to be able to work out the standard error. So the standard error formula, or standard error of the mean, is a straightforward formula. We're using the sample standard deviation here, S, and divided it by the square root of n, which in our case is 14. So we have the two values here. So let's go ahead and work this out. So that is equal to a standard deviation of 5.65 divided by the square root of 14. Let me get my calculator out and work that out. So 5.65 divided by, put in 14 and use the square root symbol to get that, and then press equals, and that will give me a standard error of 1.51. I'll use 2 decimal places there. So now we've got the standard error, and our next job then is to multiply our standard error. So we want to multiply our standard error multiplied by our t-value. So that is equal to 1.51 from here multiplied by 2.160. So let's work that out. So we have the 1.51 still in our calculator. Multiply that by 2.16. That is equal to 3.26. So now we have the value that we need to estimate our upper value and our lower value for the confidence interval. So let me put in the upper one first. And that's going to be equal to my mean, 996.21, plus this value that I've just worked out here. So that's going to be 996.21 plus 3.26. And that's going to be equal to, let me work that out, my calculator. So 996.21 plus 3.26 is equal to, so that's 999.47. And my lower limit for the confidence interval is equal to the same mean value again, 996.21 minus 3.26, the same value we worked out up here. And that is equal to, let me work that out, 996.21 minus this time 3.26, which is equal to 992.95. So my confidence interval then for the mean is, my lower limit is 992.95 up to my upper limit here, 999.47. So I can now say with 95% confidence that the population mean lies between these two values. If I wanted to do 99% confidence, the only thing that's going to be changed is this t value over here. It will be a higher value for a 99% confidence, and this margin here will widen. So our CI here is equal to plus or minus 3.26. So that's this value here. Now, so that's how you calculate the confidence interval for a sample. I hope you found this video useful. Thank you for your attention.